final major component of this section is talking about inverse trigonometric functions, taking the inverses of sine and cosine and functions like that. Well, on first blush, you might say, this is a ridiculous thing to think about, because let me draw out, here is sine of x, more or less. So here is pi over 2, and pi, and 3 pi over 2, and 2 pi, and so on and so forth. And perhaps you're thinking here, this is a ridiculous thing to think about, inverse trigonometric functions, because this is miserably, sine x here is miserably failing the horizontal line test that we talked about before. That each horizontal line should intersect our function in exactly one place. And, horizontal lines between where the values are between -1 and 1 are going to intersect this graph not just once or twice, but infinitely many times. So this seems very, very bad. But the thing to remember is that we can always restrict down the domain of our functions to get to a point where they would be one-to-one on a given domain. And so what we're going to do is, well, this is going to bottom out at minus pi over 2. We're just going to look at sine of x on the domain from minus pi over 2 to pi over 2. And on that domain, it'll be one-to-one. So we'll be able to construct a inverse function for it. So for sine of x, we're going to only look at the domain from minus pi over 2 to pi over 2. And so the function looks something like this on that domain. Plus 1 to minus 1. And so then, so the range here is from -1 to 1. And so when we rotate it, or it's not so much rotate, I should say, but reflect it over the line, y is equal to x. The graph of it looks like this. So we interchange the roles of the domain and the range. So the range was -1 to 1. That's the domain of our new function, and vice versa. And so it looks something like this. So this would be the inverse sine function. For cosine x, we choose to restrict the function, the domain, from 0 to pi. So cosine of 0 is 1, cosine of pi over 2 is 0, cosine of pi is -1. So again, the range is from -1 to 1. And so now we draw a new function for the inverse. So the range now is going from 0 to pi. The domain is -1 to 1. And transferring this, reflecting, we end up with this kind of function here for the inverse of the cosine function. And so from this, we end up, let me get my slides in order here, the definition of arcsine and arccosine. So y is equal to arcsine x is the number in the interval from minus pi over 2 to pi over 2, for which sine of y is equal to x. Y is equal to arccosine x is a number in the interval from 0 to pi, for which cosine of y is equal to x. And so I should note here that I'm using arcsine and arccosine. We also sometimes write this as y is equal to sine inverse of x, and y is equal to cosine inverse of x. So arcsine is this, arccosine is this. In the next video, we'll talk about the other inverse trigonometric functions. They work in just the same way. So now let me bring back the slide that was out of order here. So just a couple of quick examples here. So arc sine of root 3 over 2. So that is the number in the interval from minus pi over 2 to pi over 2, for which sine of y is equal to root 3 over 2. And so a little bit of thought, pi over 3, sine of pi over 3 is equal to root 3 over 2, and pi over 3 is in fact in this interval. For arc cosine of minus 1/2, we're looking for the number in the interval from 0 to pi, for which cosine of y is equal to minus 1/2. And a little bit of thought says that that should be 2 pi over 3, if I'm not mistaken. So I should point out that there are many other values of x for which sine of x is equal to root 3 over 2. You know, for example, you might say, why not 2 pi over 3 here? But 2 pi over 3 is outside the interval, so we are restricting our domain to only think about these particular domains here. And you might wonder why these domains and why not some other natural domain, and that's a fair question to ask. But these are the domains that mathematicians have used here. And so let me end this video with one classic problem here. What is sine inverse of sine of pi over 4? So sine inverse of sine of pi over 4. So we think about sine of pi over 4 is going to be root 2 over 2. And so we end up back at pi over 4. And so life is good, because sine of pi over 4, we know that is root 2 over 2. And sine inverse, arc sine of root 2 over 2 is pi over 4. And that does, in fact, fall into this interval here. And so you might say, oh, we're just canceling out, the inverse sine of sine here. But let me change this just a little bit. What is sine inverse of sine of 9 pi over 4? Now, if you think for a moment here, you should realize that sine of 9 pi over 4, if I've done this correctly, I just added 2 pi to pi over 4 to make it 9 pi over 4. So sine of 9 pi over 4 is going to be the same as sine of pi over 4, so that's root 2 over 2. And the inverse sine of root 2 over 2 is equal to pi over 4 is not equal to 9 pi over 4. So here's a case where we can't just cancel out inverse sine and sine. And so if we go way back, let me see. Yeah, this is I'm digging out from my pile of previous notes here. So this says that we should end up back where we started, f inverse composed of f of x equal to x, for all x in the domain here. But here things are getting tricky, and so because this 9 pi over 4 is, we've had to restrict down. So we might say, oh, 9 pi over 4, well, that's in the domain of sine of x. But remember, we had to restrict down the domain. When we're talking about arc sine, the only domain we're caring about is minus pi over 2 to pi over 2. And so this property is failing right here. So common mistake people have, just cancel those two things out and say it's 9 pi over 4. But that leads you to the wrong answer.